Hello everyone, good to see you again. Hope you are in the very good condition. Okay, in this time we will try to discuss about the still the same with the previous video, HP separator and the emergency, but in this video we will talk about the block discharge scenario, and there is some new aspect. This one, this HP separator equipped with the pressure control valve, the main pressure control valve, and the secondary pressure control valve. So actually, for the downstream equipment, the gas will flow to the downstream process, or let's assume that this gas will flow to the metering system, and this second one of pressure control valve will release or relieve the excess pressure that comes from the operational fluctuation, or let's say if this downstream equipment there is some blockage, this pressure control valve will act as the basic process control to release the excess gas to the flat. And in this video we show that there is no pressure switch. So actually after PPCS, the next layer of protection is the pressure safety valve. Let's change this one to PSV. The same with the previous video, we start from specify this component list. Here you can refer to my composition data, and for the fluid package I chose Ben Robinson. For the composition of gas you can refer this one, and for the operating condition, temperature, the pressure from boundary, outer boundary system is 800 per square inch, and for the molar flow, assume it will be 15 million scuff per day. For the valve itself, you can follow me for the specification of the flow control valve. For the pressure control valve here, for the level control valve here, you can follow me. For this discharge valve dummy, this opening of this valve will be set to 0 to represent when block discharge happen. So let's set, as in this one, you can use this data for this discharge valve dummy. Actually, this is not actual data. And this one for the PSV, pressure safety valve, we'll set the pressure at the 100 per square inch, and for the full open pressure, let's say the 550, 50% of the set pressure. I'm sorry, 10% from the set pressure. And for the control loop, still the same with the previous one. For the level controller, still the same, and the difference is we use this split range control to control the pressure control valve. Here for the first one, the output target object is this pressure control valve, this one, And for the second one is this pressure control valve, secondary pressure control valve, to release the excess pressure to the flat. With the measured variable is the vessel pressure. With the one transmitter and one controller will manipulate this control valve and then the secondary pressure control valve. You can refer to the specification for the coefficients well, and for the split range setup here. In low range or high range is the output of the controller, and after 50% the secondary pressure control valve will open. Here we can see the curve. Okay. As the main pressure control valve increase after 100 and the pressure still increase, the secondary pressure control valve will open as well to stabilize the pressure of this vessel. You can use this, you can refer to the specification. And for the PSV, pressure safety valve, since we will this pressure safety valve will handle the blocked discharge valve, let's assume that the orifice standard will be the, or perhaps about the 1.3 square inch of the area of orifice will be used in this study. Afterwards, let's go to the dynamic tab and choose the chart to select the parameter we want to monitor in the study. Yeah, basically I already specified several parameters here. I will monitor the vessel pressure and then the molar flow of this secondary pressure control valve, then the swan flow control valve itself, and the flow to the pressure safety valve, and the main of pressure control valve. Don't forget to select this one, automatic auto scale, and axis show all. Okay, you can add, if there is more parameter you want to add, you can select the edit, and here you can select in this one. And before we change to dynamic mode, let's assume we already set the boundary condition here. In this study, I will choose this pressure specification. And here, for the pressure specification will be indicated by this green color. You can select this one. For the default, the pressure specification cannot be seen, but if you choose this one, we can see the pressure specification at order of our boundary condition system, boundary system. For the event scheduler, I will not use the event scheduler, so let's neglect this one, drip chart, yeah. And auto scale all axis. Before we start our dynamic models, let's choose the integrator cell and choose the acceleration. We want to observe what will happen, so let's decrease this acceleration to 0.01. And all already said, actually the scenario we want to observe is during the normal operation, there is suddenly blockage of downstream equipment. Let's assume that the downstream equipment is the metering, or you can specify what you want. This valve will be set to 0 to represent the blockage, and afterward, after this pressure control valve cannot longer maintain the pressure of this vessel, the secondary pressure control valve, the control with one control loop or split range controller, will be open to release the excess pressure, and if the pressure of this vessel continues to increase, the pressure safety valve will be open to save the equipment. And for the rating, I changed to H, and perhaps in this video we will also want to see what will happen if the pressure safety valve orifice is under design. For the first one, let's change the orifice design to H. Okay, select the one. Let's assume at minute of 10 there is suddenly blockage of the downstream equipment. Then here you can see the secondary pressure control valve cannot handle the excess pressure. As the pressure continues to increase, the pressure valve will open to release the excess pressure. And the flow to the downstream equipment is already blocked. So by monitor this strip chart, we see that all of the gas produced from the well all will be going to plan. But actually this is just the conceptual study. In actual condition, there is pressure switch that connect to shutdown system. Before the pressure exceeds the pressure safety valve, the pressure will trigger the shutdown system, and this one will be set close so that the flow from the well will be fully closed. So since this one is conceptual study, so we assume that the flow is continue to flow to our HP separator system, and once this discharge is blocked, the secondary pressure control valve will open, and as the pressure continues to increase, this pressure safety valve will open as well. So the vessel rupture will not occur in this study. Yeah. So actually design of this orifice area selection is already adequate that can accommodate the relief flow, and then we want to see what will happen if the orifice area is under a design. Let's start again. Yeah, then the pressure will going to increase here, increase violently until the system is equilibrium with the outer boundary, the pressure, which is 800. And if this outer boundary system is, let's say the 1000 pound square inch, this also will going to increase as well, as this one is under design. So that's to give you a picture what will happen if we choose the wrong of the orifice area. So the orifice area under design, catastrophic phenomenon can be possible to happen. Let's change again to H, then the pressure will increase. So that's the point. We have to select the appropriate orifice area. You can use standard from API 520, 521, or 527 to select the orifice area. And afterwards, let's say the operation team can handle the cause of the blockage, the system will be back to normal. Here, the purple one will increase, indicating that the flow to the downstream equipment, let's assume the measuring system and the gas buyer, is going to be normal again. And we will see that the PSV and the pressure control valve is set to 0 again. If the blockage is only partial blockage, what will happen? So if the pressure partially blockage occurs, this pressure control valve, secondary pressure control valve, will able to handle the pressure. We'll see that the pressure of this vessel still in normal condition, not increase violently. It indicates that if the partial blockage occur, the basic process control system can handle the situation. But actually, if the fully blockage occur and we assume that there is no shutdown system in, or let's say the shutdown system is failed, the PSV will be open to release the exhaust pressure. And I think that's all about this video. I hope this video is useful for you to give you a picture what will happen if the blocked discharge scenario occur. See you on the next video.